Good morning, everybody. My name is Giovanni Betti Beneventi. I'm a PhD student here at the University of Modena and Reggio Emilia, and also at CA Leti Minatec Grenoble, France. The supervisors of my doctorate for the Italian part are Professor Paolo Pavan and Professor Luca Larcher. The topic of my presentation is characterization, modeling, and architectural design of phase change memory or PCM devices. So just a slide to introduce the topic of the phase change memory. The PCM device, as you can see in the figure on the left, is basically is a very simple device made by a phase change layer indicated as PC in the figure, sandwiched between two electrodes, a top electrode indicated as TE and a bottom electrode indicated as BE. At the heart of this device, there is the phase change layer. The phase change layer is constituted by a chalcogenide alloy, that is a special material, that if appropriately heated by applying suitable electrical pulses, so by exploiting the Joule effect, can switch between two different states of the matter: a polycrystalline high conductivity state and an amorphous low conductivity one. So this reversible phase change enables to store a logic 1 or a logic 0 in a non-volatile way. So basically the phase change memory is a non-volatile memory device that is based on this very special material. The phase change technology is considered very promising for the future of non-volatile memories. In particular, PCM features higher programming speed, ameliorated endurance, and better scaling capability compared to the flash actual non-volatile mainstream. PCM is not the only emerging non-volatile memory technology, but has been the first one to enter the memory market. In 2010, a 512 megabit device by Samsung and a 1 gigabit device by Micron have been delivered to customers. Moreover, we find many research activities in companies, in big semiconductor companies like Intel, IBM, or Hitachi. We have also many research centers that are very active in this field, and my PhD work takes its place in the framework of a project aiming to develop a PCM device for embedded application that is carry out, it is a collaboration between Leti and ST Microelectronics. Speaking about the activity, my activities in 2010, from January to October, I was with CA Leti Minatec in Grenoble, France, where my main activity was the characterization of phase change memory devices employing novel chalcogenide materials. In particular, we integrated for the first time carbon-doped germanium telluride, and we show how this new material improves data retention performances and reduces the programming current compared to the standard PCM devices using standard phase change materials. The results of this work has been published in IMW, ESDERC, ECMTS, and EPICOS conferences on an EDL paper. We have also filed a patent on the electrical characterization procedure, and we have submitted a review paper to Solid State Electronics. At CA Leti, my background activity has been the exploration of new circuits based on phase change memories for reconfigurable FPGA applications. We have shown that using phase change memory instead of the traditional flash solutions leads to a reduction of a factor 1.5 in the area and an increase of 16 times the speed of the overall system. On this topic, we have 2 patents deposited, and I am a co-author of 2 conferences in the field of FPGA applications. Back in Modena in October, I started mainly 2 projects. The first one is the modeling by means of analytical methods and FEM simulation of the self-heating effect in polycrystalline PCM cells. And the second one is I have started a characterization study of low-frequency noise processes in novel phase change in phase change devices integrating novel phase change materials. About these works, we plan to submit a paper to the transaction on electron devices soon, probably next month, about the self-heating effect. And we are carrying out also the other activity on the low-frequency noise using an experimental setup developed by Professor Borgarino and Valerio Doga. About my PhD thesis planning, I am in the 3rd year of my doctorate. The idea is from now to the end of the doctorate is to continue these 2 studies and conclude the low frequency noise study and the self-heating effect modeling. This is a selection of my publication. And I have concluded my talk. Thank you for your attention.